clarify to you what the difference between the pair t-test and the pool t-test. All right. So you may know, you may have questions. Okay, what does it mean the pool t-test and the pair t-test? Okay. All right. The pool t-test. Okay. The pool t-test, that you should understand that the condition of the variance must be equal. Okay, the variance, right? The variance, okay, the variance must be equal. Okay, so that the assumption we just said. For the pair t-test, okay, the pair t-test, the variance may not be equal. Okay, the variance may not be equal. So that you should understand. Okay, the difference between the pair t-test and the pool t-test. Okay, all right, now. So now we're going to do the hypothesis testing with the dependent sample. Okay, so let's see what does it mean the dependent sample. So this is a learning outcome number 3. We do the test hypothesis about the mean population difference between paired or dependent observation. Okay, paired or dependent observation. So well, let's see first what does it mean that the paired. Okay, so dependent samples are samples that are paired or the related in some fashion. Okay, for example, you can see if you wish to buy a car, you look at the same car at 2 different dealership and compare the price. Okay, so this is the same car. Okay, the same car, but you looking at the price from the 2 different dealership. Okay, all right, now another example, if you wish to measure that the effectiveness of the new diet, you would wait. You would wait that the dieters at the start and the finish of the program. Okay, so this is before and after. Okay, usually this category is that the before and after. Okay, when you do the diet, you can see that you measure your weight. Okay, before and after, same things. Like another example, say your score in the business statistics subject before do your revision and after do your revision. Okay, that's also like pair t-test. Okay, that's we call as dependent samples. Okay, before and after. So you check that the list of number of students taking an exam before that, the revision of the business statistic, and then we get the result, and then you compare that with another set of data after they done the revision on the business statistic. So we have the 2 set of data. So, but the 2 set of data as a relation, which is before and after. So this is what they explain here. Okay, dependent samples. Okay, for the 2 set of data. Okay, moving on. Okay. So in order to do that in the dependent sample, so we have a formula, the t-test, okay, t which is equal to the mean of the differences. Okay, this is the mean of the differences over the standard deviation of the differences. So denote as the SD over the square root of the number of pairs. Okay, so this is a size, the number of pairs we have. Okay, so that is square root of n. Okay, then you know all this, then we can able to compute the t value. Okay, so remember this formula. Okay, take a look at this example, which is related to that the dependent samples t-test. Okay, nickel savings and a loan wishes to compare the 2 companies. Okay, so first company is that they call Skadek and another is Bowyer. Okay, So it uses the appraise that value of the residential home. So this appraisal value, okay, and the two different companies, okay, there is a 10 residential properties is given, and the schedule both firm for the appraisal and the result reported in hundred thousands. Okay, so it's given in that the table. So 235,000, and this is 228,000 based on the SCADAG and Bowyer. All right, at the significant level 0.05, so the means of 5% level of significant. Can we conclude? Okay, can we conclude there is a difference in the mean appraised value of the home? Okay, is a difference. Underline the words. That's what how we're going to develop that our hypothesis statements. Okay, now we have a two set of data. Okay, so we do the compare that the prices. Okay, all right. Now first step. Okay, we're going to check. We need to write that the null hypothesis state and null and alternative hypo statements. So the question wanted to check is different. Is there any difference? So that means you should know that equal or not equal. So first we set that your null hypothesis. Okay, the mean value. Okay, the mean value is not equal to 0. Okay, the mean of okay, the appraised value of the homes, okay, not equal to 0. Okay, and then we said that the appraised values is equal to 0. Okay, all right. So we just develop that two set of the null hypothesis, and the alternative hypothesis. Step 2, we need to set that the significant level. We know that is a 5% significant level. So we already set. Third, we need to select that appropriate test statistics, right? Okay, now in order to test that the two population mean with the dependent samples, okay, so we're gonna use the t statistic. For this is we're going to use the t statistic because it's a depend one to another. Okay, now how are you going to do that? So we see that the t stats based on that the formula. So we set the rules. Okay, so we call as decision rules. If the t is greater than the t critical value, which is 10%. Okay, so this equals, that means we have a two-sided or two tails normal distribution curve. So t alpha over 2 n minus 1, or t less equal to minus t alpha over 2 n minus 1. So this we need to consider when you look at the table, the critical value at the 10%, okay, 5% equal both sides. So we get a 2.262. So you can see that in the table. Okay, so this is in the curve. This is 10% divided by 2, so here. Okay, the alpha value is minus 2.262. And then this side as well. Alpha is the mean value. It's 2.262. Okay, now, so we look at the table. So this is, we look into 10%. So 10% means we should consider that divided by 2. So it means it's 5% every one of each side. Okay. So if you refer to the table, the t-stats tables, you get 2.262. So you just write down your value, the critical value at this region. Okay. So this is your p-value. Okay. The p-value, the corresponding value is a 3.58. at the significant level of 0.01. Okay, because we not intend to just look for the significant value for this, so just only need to know that the t value. Okay, step 5, need to take the sample and make a decision. Okay, so we do the t test, the statistics test based on the formula that what we have. So first we need to find the mean value for the difference. So we have 46 over 10 sample number of samples. We got a 4.6. And then we look for that the standard deviation for that the data, you know, the differences. So square root of sum of d minus mean d over a square over n minus 1. So we get a 4.402. So just now we just saw the formula, right? So t equal to mean of the d over sd over square root of n is the formulas. And we substitute that all this value that we obtain, and we get a t value is a 3.305. So which mean is that, okay, so we see, okay, yeah, we can simplify it in that form of table. So we got the 3.305. So we compare that the t value with that the critical value of the t that we obtain. So which means we have noticed that the 3.305 is greater than the higher critical value, which is 2.262. So which means our decision is to reject that null hypothesis, because if you can see that it is fall in this region, the greater than the critical value. So 2.262. So I mean the t value is fall somewhere here. Okay, it's fall somewhere here. So that means 3. What is that? 3.305 to 3.305. So it's greater than the 2.25. That means it's fall in the critical region when you just consider it. Likewise, here is a minus 3.305. So the t value. So t value is less than for this case. Okay, on the left hand side is less than minus 2.262. On the right hand side is a greater than 2.262. So which means we reject the hypothesis null. Okay, our decision is to reject the hypothesis null hypothesis. Okay, all right. So after that, you just interpret the result. The data indicate that there is a significant statistical difference in the property appraisal from the two firms. So when you consider the two firms, okay, Skedek and Bowyer, so you can see that there is significant, okay, appraisal difference based on that the properties they evaluate. Okay, all right. Okay, now moving on, we're going to explain that the dependent versus the independent sample. Okay, so how do we differentiate between the dependent and the independent sample? Okay, it's very simple. There is some procedures. First, we need to know the dependent sample are characterized by the measurements followed by the intervention. So interventions means something like before and after. Okay, so it's connected one to another. Okay, so that the first thing. Or the dependent sample are characterized by the matching or the pairing observation. Okay, so say for example, we take the same basic, so business statistic, so we do the measurement right before and after that exams. Okay, so that we call as a dependent and independent samples. Okay, these are dependent samples, how they relate. For the independence, okay, so you all know, right? Two different things. There is no related one to another. Okay, so you should know that how to see that the dependence. Okay, even though they form the same cluster, but it has before and after. Okay, all right. Now, why do we prefer dependent samples to independent samples? Okay, the thing is, by using that the dependent sample, we are able to reduce that the variation in the sampling distribution. So that's the only reason why we should prefer that dependent samples to independent samples. Okay, because the variation, I mean the error will be you can reduce.